Hey everybody, George Jefferson here. I'm going to split this lesson up into two because it just took too long on the first one, so I'm just splitting it up into two. We'll cover the slant asymptotes and some vertical and horizontal asymptotes and general rules. And then in the second part, we'll do the direct, inverse, and joint variation. Okay, let's go ahead and review this guy right here. Okay, so graph 1 over x minus 3 plus 2. All right, remember 1 over x, I don't have a graph for that, but 1 over x was, if this is your y-axis and this was your x-axis right here, it made a graph that went in this quadrant 1 and then over here in quadrant 3. Remember that right there? This is going to be the same thing, except it's going to be shifted to the right 3 and up 2. So there it is, shifted to the right 3 and up 2. So my vertical asymptote is x equals 3. My horizontal asymptote is that plus 2 right there. All right, nice and easy. Okay, so remember this is part one of slant asymptotes, and we'll do the part two of the direct, inverse, and joint variation. And the homework is on part two. Okay, you guys that are in my class. Slant asymptotes happen when the degree in the numerator is one more than the degree in the denominator. Okay, so then what you have to do is long divide from algebra 1 / algebra 2 to get your equation of your slant asymptote. And I know a lot of you guys forgot how to do that, so I'll remind you. Okay, so determine the slant asymptotes for each function and then graph. Okay, here's the first one. F of x is 2x squared minus 3x plus 2 over x minus 2. First of all, I know it has a vertical asymptote at x equals 2 because that's what gets me 0 in the denominator. And since this is x to the first and this is 2x squared, then the degree in the numerator is one more than the degree in the denominator. So I'm going to go ahead and long divide. Okay, so long divide is I do this. This x times what gets me 2x squared. And so x times 2x will get me 2x squared, so that's what I'm going to write right above there, 2x. Then I multiply 2x times x and 2x times negative 2, and I write it right underneath here. And then I subtract them, but I got to put parentheses around those to subtract them. Okay, and then the 2x squared minus 2x squared cancels. Negative 3x minus a negative 4x is negative 3x plus 4x, which is 1x. Now I'm going to slide down this plus 1 and then do it all over again. I'm going to go this x times what gets me 1x, x times 1 plus 1. So I'm going to put plus 1 right there. Then I multiply the plus 1 times that and times that. That's what I write underneath that right there. And then you get a remainder of 3. Remember 1 minus a minus 2 is 1 plus 2. Okay, now asymptotes happen when x goes to infinity, you guys. So when x goes to infinity, the remainders become insignificant. You can drop that off. So I'm going to go ahead and cut that off. And here's my slant asymptote right up here, y equals 2x plus 1. Remember, the remainder drops off. Okay, there's the slant asymptote. Y equals mx plus b. Remember how to graph that? It's an asymptote, though, so it's a dotted line. X equals 2 is a vertical line. So there it is right there. Okay, now how to graph this part, we'll get more into detail later, you guys. For now, just be able to plug this equation into your calculator, okay, and then you'll understand the asymptotes from your work that you just did, okay. But you can plug them into your calculator and you can see this graph in general. They just won't tell you what the asymptotes are. You have to calculate those yourself, you guys. So we did that ourselves. Okay, so this one right here, we're not going to have enough room for this one, although I'll kind of show you. Okay, notice how the degree on top is x squared, the degree on bottom is x, so this is the long division. Remember, I have a vertical asymptote at x equals negative 4. Okay, so I'm going to go ahead and long divide. So x times 4x gets me 4x squared, and then I multiply 4x times that, and it gets me 4x squared plus 16x, and I subtract 6x minus 16x is negative 10x. Bring down to negative 37, x times negative 10, whoops, right there, x times negative 10 gets me this negative 10x. So I multiply negative 10 times x, negative 10 times 4 gets me negative 10x minus 40. And then when I subtract, remember the remainder drops off, you guys, so your slant asymptote is y equals 4x minus 10. Remember the vertical is x equals negative 4 from our last lesson. Okay, and when you plug it in your calculator, it looks something like that. This equation is, this asymptote is y equals 4x minus 10. This asymptote is x equals negative 4. But the part you don't see, you guys, is down here where they intersect is like down at negative 90 something. I don't know. I forgot where it was, you guys. So your graphing calculator just, you can't see it. You can't see your grids on there. If you hit your view window, you can see it goes way down when you do that. All right, so and then if your calculator is not graphing, go ahead and hit graph and then hit zoom fit. I think it's zoom 0 and it fits to the data that you're dealing with. All right, so here's a general rule for asymptotes. If the degree in the numerator is one more than the denominator, then there's a slant asymptote, and you have to long divide. Okay. Whoops. So if the degree in the numerator equals the degree in the denominator, I clicked it one too many times, then you have a horizontal asymptote, and your horizontal asymptote is y equals whatever the simplified form of your leading coefficient is. And it's this easy, you guys. Remember, when you're going to x infinity, that's where you get your asymptotes. This minus 1 becomes insignificant. This minus 2 becomes insignificant. And I'm left with 3 times infinity over infinity, or 3x over x, which is 3. That's my horizontal asymptote. Okay? So if the degrees are the same, then you just reduce the leading coefficients, and that's what your asymptote is going to be, your horizontal asymptote. And if your degree in the numerator is less than the degree in the denominator, then you have your horizontal asymptote at y equals 0. All right, I think, let's see. Okay, and vertical asymptotes, don't forget about those. Those are the x values that make 0 in the denominator. We talked about that in our last lesson. All right, so let's go ahead and try this, you guys. Graph this guy. Okay, now first of all, you got to recognize, before I do this, you got to recognize that if I FOILed that bottom out, it became x squared minus 1. So notice the degree in the denominator is greater than the numerator, so the asymptote is horizontal is y equals 0. Okay, I have x asymptotes, or x vertical asymptotes at x equals -1 and x equals +1. So here we go. And so there's my general graph right there. Okay, now we'll learn how to graph those later, but right now you can plug them in your calculator. I just want you to know where these asymptotes are, because your calculators won't give those to you, and you get a graph that kind of looks like that. Okay, this is x equals -1, this is x equals +1, and they don't do this one in a dotted line, but this is y equals 0 right here. Okay, all right, let's see. Okay, so this is going to be part 2. I'm going to stop it right here.